Hi and welcome to the Mathemagic channel. Let's look at this question which has gone absolutely crazy on the internet. So let's see if we can do it. Well, I've seen some really complicated solutions to this online. Well, the first thing is I notice I have a system of three equations with three unknowns. And so I really encourage you to label your equations when you do this kind of work so that you know which one is line 1, line 2, and line 3. And you can also explain to your teacher what it is that you're doing. Now, as a little caveat, I am not entirely sure whether this is really a Math Olympiad question because the style of it seems different to what I'm used to from Math Olympiads, but it might be. So why not try and think that, yay, we're doing a Math Olympiad question. So we notice that we have three products. A times B is equal to 10 here. We have B times C is equal to 20 here, and C times A, which is equal to 30 here. Now, it doesn't have to be that A is 1 and B is 10 or that we have whole number values. It could very well be decimals or anything else. So let's not make any assumptions about the final result. And in the end, we want to find A plus B plus C. So we need to find all three variables and add them together. So I do notice that it is possible from line 1 to express B in terms of A if I was to move the A to the other side. And it is possible in line 3 to express C in terms of A. So perhaps I should be doing that, and then I might be able to find the value for A specifically. So I'll explain what I mean here. So from line 1, I'm going to say that B is equal to 10 divided by A. So if you move a variable from side to side, time can become divide. So I'm moving the A times B to the other side, and so the A was at the top and he goes to the bottom. And then from line 3, I notice that C times A is 30, and using the same logic, I'm going to say that C is equal to 30 divided by A. So those two elements are good because they can go back inside of line 2 here. So in line 2, using those facts, in line 2, so instead of writing B, I'm going to write 10 over A. And instead of writing C, I'm going to write 30 over A. So let's try and do that. Then if we have everything in terms of A, we could be able to solve it. So 10 divided by A instead of B, and then 30 divided by A instead of C, and that will be equal to 20. So one cool thing that I can do here is I can realize that at the top I have 10 times 30, which is 300. So I can say 300 equals 20. And then I was dividing by A times A, which is A squared. So in mathematics, when you do A times A, you get A squared. Now, using the same logic as before, moving the A squared to the other side, divide becomes times. So I can say that this is 300, and 300 is equal to 20A squared. So the A squared was a division, and it moved to the other side and became a multiplication. Now, following my reasoning, I'm going to go here and say that the 20 is multiplied by A squared, and so 20 can move to the other side and become a division. So 300 divided by 20 equals A squared. And so 300 divided by 20, it's the same if I cross out 10 from both sides as 30 divided by 2. So that's equal to A squared. And 30 divided by 2, well, that's 15. So I can say that 15 is equal to A squared. Well, this is looking pretty good as a starting point because I've almost found the value of A. So this is pretty cool here because if I square root both sides, I end up with A equals the square root of 15. So I found a value for A. I will say, however, that whenever you think about numbers and you square root both sides, you need to consider the positive square root, but also the negative square root. That is because if I say, for example, that A squared is equal to 4, well, you could say that 2 squared equals 4, so that's correct. But you could also say that negative 2 squared, well, that's also 4. So in the end, A is equal to plus or minus 2. And so in this case, it's a little bit similar. We could have the positive square root of 15 or the negative square root of 15. So we really need to consider both because nothing in the question tells you that you're not allowed negative values. So I am going to consider both options and say, let's imagine that A is equal to the positive square root of 15 and then see where we go from here. So if A was the positive square root of 15, then I can see from this equation here that b is 10 divided by a. So b would be 10 divided by the square root of 15. And I don't really like leaving the square root at the bottom because that's kind of not how we do mathematics. We don't like to leave roots at the bottom of expressions. So I'm going to multiply the top and the bottom here by root 15. So I'm going to get b equals 10 root 15 over root 15 squared. So this process is called rationalizing the denominator. So multiplying the top and the bottom by the square root of 15 to get rid of the root at the bottom. And I end up with 10 root 15 over 15 here. So 10 root 15 over 15. And 10 divided by 15, well, I can divide top and bottom by 5. That is actually going to be equal to 2 root 15 over 3. So that's dividing the top and the bottom by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. So in this case, I found a value for b here. B would be equal to 2 times the square root of 15 over 3. Now I still need to find c. And let's remember, we're still in the case here where a is the positive square root of 15. We haven't done the case where it's the negative square root of 15. So c equals 30 divided by the square root of 15. Multiplying the top and the bottom by root 15, just like we did earlier for b, we're going to get 30 root 15 over 15, because we don't like leaving square roots at the bottom. And this is going to give us a c value of 2 root 15. And so we can write that down. So in this case, c equals 2 root 15. Now we haven't found out what a plus b plus c is yet, but I'm going to find the negative square root of 15 cases first, and then I'll try and complete the question. So I'm just going to make a note for myself that this is the case where a is equal to square root of 15, and we have these 3 different solutions. Now, what if a is equal to the negative square root of 15? Well, we can do the same kind of work. Of course, the results might be a little bit different. So plugging back into this first expression, number 1 here, b is equal to 10 over the negative root of 15. And this time multiplying top and bottom by negative root 15, I get minus 10 root 15 over 15. And a solution that's relatively similar to what we had before. B is equal to negative 10 over 15. That simplifies nicely if I divide both by 5. So this is 2, so negative 2, square root of 15 over 3. So pretty similar to what we had in the first case. So if I set this up like I did before, a equals negative root 15, b equals negative 2, and it was root 15 over 3. And so I still have to find the c value, which I'm going to do right now. So for the c value, I'm going to get 30 divided by the square root of a. So I can take that reasoning here. So c equals 30 over the negative square root of 15. And multiplying top and bottom by negative root 15, I get 30. So negative 30 root 15 over 15. And negative 30 over 15, that's negative 2 root 15. Actually, yeah, that's good. Negative 2 root 15. So here for my third answer, I get c equals negative 2 root 15. Now this looks pretty tricky, but we're going to have to add a plus b plus c, and I guess we're going to get 2 different sets of solution unless they look really similar. I'm not too sure. So if we look at case 1, I'm going to do case 1 here. So a plus b plus c, right? This is what we're looking for, is going to be root 15 plus 2 root 15 over 3 plus 2 root 15. Now it's worth trying to think about whether these questions are good or not. Just as a quick double check, I noticed that if a is root 15 and c is 2 root 15, well, that works pretty well for CA, because 2 root 15 times root 15 is 2 root 15 times root 15 is 2 times 15, which is 30. So I feel, as a quick double check, and I encourage you to do that when you do a math question, that we are on the right track here. And it seems to work with the negative versions as well. It's also equal to 30. So I double checked by just multiplying a by c to see if I got 30 indeed, and I do. So then I think the answers are pretty good, and I'm just going to go ahead and do the solution now. So how do I add these things? Well, I notice first that 1 is a fraction in the middle, and so maybe I need to put everybody over 3. So if I multiply root 15 by 3, that'll be over 3 as well. If I multiply 2 root 15 at the end by 3, that'll be by over 3 as well. So I'm going to say this is 3 root 15 plus 2 root 15 plus 6 root 15, and all of that is divided by 3. So what is 3 plus 2 plus 6? That happens to be 11 root 15 over 3. And I just want to point your attention to the fact that, so this is 11 root 15 over 3. If you were to do the 3 negative versions, so A and B and C being negative root 15, negative 2 root 15 over 3, and negative 2 root 15, you'll get exactly the same, but you'll get minus 11 root 15 over 3. So just to save time, I'm just going to say that case 2 is going to be exactly the same thing, but the result of which will be minus 11 root 15 over 3. So I'm not going to do this calculation again because it looks to be exactly the same as before, just with negatives in front. So it looks to be that A plus B plus C, that can be equal to 11 root 15 over 3. But it could also be equal to, so A plus B plus C could also be equal to negative 11 root 15 over 3. So probably one simple way to write this down is to say A plus B plus C equals plus or minus 11 root 15 over 3. And I'm going to say that this question was quite interesting. I didn't realize it was going to be so deep when I started doing it. I thought it was going to be relatively simple. It's not that complicated. It's just that through the roots we realize that A has a positive and a negative value, and it's a surd. So maybe manipulating square roots and realizing how to rearrange them when they're at the bottom and rationalizing denominators. There are quite a few skills in this question. I hope you enjoyed doing this question with me today. Please remember to like and subscribe to the Mathemagic channel so that I can bring you more math questions and we can practice math together. Until next time, see you on the Mathemagic channel, and bye-bye.